what's the learning nugget? What is this? How does this work? The learning nuggets, as Christian said, we will do these about once per month, and we want to put some very focused, small parts about specific things in Unreal Engine into these learning nuggets. That's why they're called a nugget. So very short courses where you can also follow along. And the first one we will do today is VR. So what we will do is we will quickly cover what VR hardware is currently available and what is popular, what was in the past and what is now, stuff like that. Then we will jump over into Unreal Engine and talk about a basic VR setup. I already prepared this for us, as the learning nugget is a small thing. We need to prepare a few things that maybe you can also find information on in the documentations and on other places, but we really want to go into a few very focused things like what we will do today. We will later go on and create a revolver, a gun, and shoot with that in VR. So we will do a basic VR setup. We will talk about OpenXR. We will talk about the enhanced input system, because we will use that for virtual reality. And we will then do the revolver sample. All of that in just, I don't know, 2 hours or something like that. So without losing any time, I would now go on with exactly what you're seeing right now. And let's talk about what VR hardware currently is available and what is popular. So just about the general availability. In 2023, we just have January, the first 2 weeks of January 2023. So there will be a lot of things coming this year, but just what do we have right now? And the most popular one is the Meta, Oculus, Facebook, or the same Meta as the company on top, Quest 2. There's also the Quest Pro for professionals, a very pricey option, but it's basically a Quest 2 with extras. The Quest 1, which is the predecessor of the Quest 2, also a standalone VR headset. And there's also the Rift and the Rift S, both VR headsets that are just available for PC. So all of these Meta VR headsets share one thing. You can use them with a PC. Not all of them can be used in standalone, but all of them are available for PC. And that is also what we will be doing today. We will today only cover using PC VR, because there's also the option to package the application that we are creating and put it directly on the standalone headset. That means you don't need to have a PC anymore. You can just take this with you, go somewhere, start your application there. But that requires some extra steps, which, yeah, maybe they would be too much for this learning nugget today. So we will stay with PC VR. Also, there's the Valve Index. Valve, that's the company behind Steam, and they have a different approach. They don't have these cameras on the headset. For these Valve Index and other Lighthouse-based systems, that's the code for the name for that. Lighthouse systems, you need to prepare your room. You need to set up some base stations, they are called, and your VR hardware is tracked by the base stations in the room. So you cannot just take your VR headset anywhere. You need to be in a prepared room having these base stations. Then there's also the HTC Vive and different variants and revisions of the HTC Vive. And all of them share the same thing, the Lighthouse system. So you always need to have a room prepared. I've got a very good source I would like to share with you. You still see my screen, right? Great. So this is the Steam hardware survey. And I love the Steam hardware survey because you can get a lot of very, very, very interesting information from it. And the information that I want to show you is the amount of VR headsets in the market by their percentage share. So we can easily identify that just on PC VR, just on Steam, the Oculus Quest 2 right now is by far the most popular choice, followed by the Valve Index. Then again comes the Oculus Rift S, then the HTC Vive, and so on. So you see this list. There are also some other manufacturers like the Windows Mixed Reality headset system or the Pico systems in here, but they're a rather small share in comparison to the other ones up here. So Oculus Quest 2, it's this device over here. That's at the moment the most popular choice. Doesn't matter if it's for standalone VR or for PC VR, as you can see over here. As I said, there are also others, really small percentage, really small share in the market, but these are the most popular choices. As I said, we also need to address not the hardware side, but also the software side. So one thing that I also, before jumping into Unreal Engine, want to show or want to talk with you about is OpenXR. OpenXR is, yeah, basically part of a driver, you could say. This is OpenXR. OpenXR is an abstraction layer that you can put or that you put in between the actual hardware, like your Oculus Quest device, your HTC Vive device, and so on, and your app. Because in the past years, it was totally normal to, when you're porting, so you're creating your application to run on multiple headsets, you're doing a port of your application, you need to change a lot about your Unreal Engine project. That means you had to change, oh, now this is working on HTC Vive, now this is working on Valve Index, now this is working on Windows Mixed Reality, now this is working on Quest, now this is working on PlayStation VR, and so on. And with every additional platform you wanted to go for, it became more hard to actually do the job. Now with OpenXR, you are just targeting with your Unreal Engine project OpenXR, and that abstraction, if this is now running on Quest, on Valve Index, on HTC Vive, or whatever other platform you have, that abstraction is done by OpenXR. OpenXR, what is that exactly? Who's doing it? It's made by the Kronos Group. They are the same guys behind Vulkan and OpenGL and some other standards. And their main focus is doing standardization. So they have a really long history in doing standardizations. They are very professional in doing standardizations. And they're also not just a single company, but actually behind that OpenXR, there are a lot of different companies. Here's a small list of them. That list even is a few years old. There are new companies now in this list as well. I mean, you see there's even the old Epic Games logo in here. This is a quite old list. So that just said about the hardware and software side. Let's actually jump into.
Robin, just wait. Give me 1 minute to support you to hook these scene
Right.
up. So, if you want to, please go one slide back, because I'm in person. There is one huge reason why you are showing up with these. So we have a lot of years right now going on in the VR market. I'm here since 2014. Robin, you also in the market since 2014. So, and we have seen a lot of headsets. And the reason why what Robin showed up with OpenXR is so important is when you look at these headset, you already see, and even if you look over all competitors, you already see that there is some kind of gold standard right now. So every headset, and it doesn't matter on what on what competitor you are going or for what software or no, for what hardware you decide, every headset can track in the room. Every headset has a 6 degrees of freedom tracking. That means every headset can orientate in the room. And every headset has at least 2 controllers. And all of these controllers have sticks. And all of these controllers have at least 2 buttons. And this is the reason why OpenXR is such a good way to start. And this is the reason why I love that Robin is passionate about everything what OpenXR does. And that is also the reason why all these competitors, even if they are competitors, working together on OpenXR, because when all these industry starts, everyone has to deploy their own SDK, because there were no regular SDK. There were no gold standard you can work on as a developer. But now in the year 2023, and obviously since 2 years before, 3 years before, you have the opportunity to directly build your application with OpenXR. And that means that when you are not going crazy with your application, so for example, when you look on these Valve index, for example, Robin, if you can just hover your mouse over the Valve index, when you look at this headset, you probably see there is a slide button in the middle of the controller, and the Valve index controller also have some special pressure features. But when you don't use these features, when you just work on a regular way, you can be really sure that your application in the end will work on all the other headsets you have seen there. If you stay on OpenXR devices and on OpenXR interactions who can be shared with all the other headsets. Yes, of course, as I said, pressure sensors in the Valve Index controllers, and probably other stuff in, for example, the PSVR2 coming out in February. They have also some special features, makes it hard for you to deploy your app on probably the most of your headsets. But right now, and then I'm ready here, I'm done. The coolest part with OpenXR is that you can be sure that your app can be played with most, or at least I will say 99% of the headsets available right now,
without you changing anything about the project. And that is the important part, because even in the past, even in 2015, 2016, we could do VR apps that were available on all of these headsets, but that were basically branches. So you're creating one branch or one base app, and then you're creating a branch just for this headset and a branch for this headset. Now one project fits them all, and that's the magic.
Yeah.
All right. So with that, let's jump over into Unreal Engine and take a look at the Unreal side from there. Before we do that, one thing. As I'm using the Oculus Quest, I need to make sure that my PC is using OpenXR on Oculus Quest, or on the Oculus system. Because per PC, you need to set up what is your OpenXR device. OpenXR as an abstraction layer does not know what of these many available Steam VR, PlayStation VR, Oculus, and so on, Windows Mixed Reality, whatever you have installed or whatever you have ready, you want to use. So in my case, as this is using Oculus, I have my Oculus software, PC software up, and in there, in the settings, general, there's the OpenXR runtime option. And you need to have this enabled if you're using an Oculus headset with your PC VR and OpenXR. If you're using a Steam VR headset, so an HTC Vive or Valve Index, something like that, a Pimax headset, then you need to go to your Steam VR settings, the small little Steam VR panel, and in there you need to activate OpenXR as the active runtime. You can do it from there as well. You just need to have it set, because otherwise maybe stuff will not work, or just not open up right, or the headset will not show anything. So I just want to clarify that. Make sure that you have the OpenXR runtime set. Now, let's open up the project that I have provided, and you should see something like this. What we will be doing is a little bit of a, revolver, cowboy, bandit scenario where you can grab pistols and shoot with them. So what we will implement today is a basic grabbing and interaction system, in this case, shooting revolvers. What we already have prepared in here is a little environment. This is coming straight from the Unreal Marketplace. I did not create that. If you're interested in the credits of all the assets that we'll be using in this Learning Nugget today, you can go in the project that you have downloaded to plugins, and in there you will see all of the credits. And when you click on them, it will also show who created this and where you can also get this from. Just mentioning that because credits for whoever made this. So what we have prepared in here is a very basic blueprinted application. In the content drawer down here, you will find that in the content of the project itself, it's basically empty because I have put everything into plugins. And in the plugins, you can find the graveyard content, which is this environment in here. And we can also find some gun particles, the Epic Games mannequin hands, the revolver, and the VR first steps. The VR first steps, that is something that I have prepared for this Learning Nugget. So this is mainly where we will be going on today. The VR first steps is consisting of a character, a game mode, and a player controller, the three most basic assets when you're creating any kind of gameplay in Unreal Engine blueprints. And also, this is featuring a BPVR hand, an actor-based class, which is basically just, let me help Noah for a second there. Noah, I see you're late. Over here in this channel in Discord, you can find the assets that you need to download. Sorry for that. All right, so the BPVR hand is basically just our hands that will be shown where our motion controllers, our VR controllers are located. Also, we've got a folder inputs, and in there, we are using the new enhanced input system of Unreal Engine 5.1. You may know this already, but with Unreal Engine 5.1, Epic Games changed the way inputs are handled in Unreal Engine in a completely different way. So whatever you may know from up to Unreal Engine 5.0, everything changed now in Unreal Engine 5.1 when it comes to inputs. These inputs are now handled as assets in here. So every action that you're creating is a single asset down here in the content drawer. And I have prepared 4 input actions in here. Grabbing with the left hand and grabbing with the right hand, as well as an interaction with the left hand and interaction with the right hand. These input actions are very simple assets. They are just internally data assets, basically just containing a few variables. In this case, what kind of value this is. Digital bool just means that you can click or unclick, so yes or no, these inputs. And that's fine with what we are doing. Now to use all 4 of them, I have prepared an input mapping context, an IMC. The input mapping context's purpose is to map all of these available input actions on a list. When I open up this IMC, I can find the input mappings of our 4 interaction left and right, grab left and right in here, and they are put on the Oculus Touch left, right trigger and the Oculus Touch left and right grip buttons. So trigger, that's this button back here, and grip, that's the button over on the side. So when I'm holding this with my index, I can do the interaction, and with the other finger, I can grab something. If you're using a different kind of VR headset, a different controller, so not an Oculus one, you may need to adjust this to the Valve Index or HTC Vive controllers. So whatever you are using. Now that we have discussed what this is, how did I create these? In Unreal Engine 5.1, it's super easy, right-clicking them, input, to create a new input action asset, and to create an input mapping context asset, and then to put both into your content drawer. What else have we got in here? The BPVR character. That is containing a very, very basic setup of a VR pawn or character that you are controlling. When I open this one up, what do we find in here? In the viewport, you will see that we have one XR origin scene component. A scene component is just an empty point in space hierarchy component. And that XR origin is containing a camera component and two motion controller components. The XR cam, it's called in here, is just a regular camera component where I made sure that over here on the right side, the lock to HMD checkbox is enabled. The lock to HMD checkbox is relevant because with this being disabled, that means that the headset will always just show one direction. And with the headset or with the lock to HMD enabled, HMD for head mounted display, wherever I'm pointing my headset in the real world, the camera will also be rotated and translated. The motion controller components over here, one called motion controller left and one called motion controller right, are both set up for our hands. The motion controller components themselves are invisible. They're just doing the tracking work. And when I take a look at the motion controller left over here, and I scroll down to the bottom, I can see the motion source is set to left, as where over here on the motion controller right, the motion source is set to right. That means that for the motion controller left, the left controller will be tracked, and for the motion controller right, the right controller will be tracked. If you don't see any of these contents that I'm currently showing, make sure that when you're on the content drawer, you go to your settings and you have show plugin content enabled. I just see over there in the Discord that some of you are looking for the content that I'm using. So if you don't see that, make sure that show plugin content, which you can get from the settings over here, show plugin content is enabled. Then you should be able to see it over here in the plugins list. VR first steps content, and there we go. So that's the basic setup we have in here. In the XR origin, we have our cam and the two motion controllers. As I said, the motion controllers themselves, they are invisible. To later make them visible, I have attached these VR hands to them. Let's open these ones up and take a look at what we have in there. The VR hand is just coming with these skeletal meshes coming from Epic Games. They're coming from the Manny and Quinn. I think this is Manny hand. I think it's, yeah, Manny XR, right? This is coming from the VR template of Epic Games. So that's the template hand we are using over here. And basically the VR hand is just that. It's just a hand mesh, skeletal mesh of a hand. The VR character, however, is setting up these hands so they are attached to the motion controller left and the motion controller right. We are doing this in the blueprint graph on begin play. Begin play, that means the moment our character, BPVR character, is loaded into the runtime, so loaded or spawned into the world. And there we're going with setup hands. Setup hands in this case is just a sub function that we are using. And in here, we're just doing two things, a right hand and a left hand, where we are just spawning it, memorizing it to a variable for later use, and attaching the hand to these. So attaching the right hand to the motion controller right, attaching the left hand to the motion controller left. The other two blueprint classes we have in here are pretty small. The VR game mode is just telling our gameplay to use our VR player controller and our VR character. That's it. And the player controller itself is just adding this input mapping context. What was that again? This input list over here. That's all of what this is doing. And in the end, you can just hit play in VR. And what you're currently getting from that is you can look around, and on your hands, on your VR controllers, you've got hands. That's it for the moment. And what we want to do is that, what we want to build up on top of that, is that we want to be able to use these guns over here and shoot these buckets. So let's take a look at what these guns are doing. Also, I just noticed that the viewport to show you over here in Zoom is super small. So what I will be doing just for a second is I will increase the size of this new window. So when I'm starting it, it will be bigger the next time. So on the player start element, the game mode is initializing, instantiating, spawning basically our character. That's why we were positioned in the scene over here. And on the right of that position, we've got two small guns. These guns are also blueprint classes that we can take a look at what they're currently doing. In the content drawer, when you go to the not VR first steps content, but revolver content, in there, you can find a blueprints folder, and there you go with a BP revolver. These 2 or 4 guns in the scene, they're objects of that class BP revolver. And the BP revolver is pretty basically set up. The weapon itself is just, as a root component, coming with a collision box. The reason for that is that the whole object can be physically simulated while being a skeletal mesh, because a revolver should be animated, doing some animations. Still, we want it to be physically simulated, so I had to do this box for physics simulation and revolver mesh for skeletal mesh component for animation playback. The revolver itself looks like this, and it comes with a weapon muzzle arrow component and a shell ejection arrow component. So we will, or I'm using these for telling where the muzzle is and where, the revolver shoots at, and also the other one to say where the bullets are, where the shells are ejected from. For the actual shooting, I have already prepared everything. So that's not something that we will be creating today. It already is created. What we will cover later is how to pick it up and how to shoot with it. So let's take a look at the actual shooting that I have prepared for us. Over here in the revolver graph, there's a shoot revolver custom event, and that is first checking if we still have ammunition, and if the ammunition is not available, we will just play back a sound, yeah, you can't shoot, click, click. But if you have some ammunition, it will show a muzzle flash special effect, it will play back a gunshot sound, it will reduce the ammunition by 1, and it will eject a shell using a Niagara system as well. So this over here and that are both Niagara systems, while the revolver gunshot sound is a sound effect that we're playing back. We are also doing a muzzle smoke Niagara system effect. And in the end, we are actually doing the shooting where we do a line trace by channel. And whatever we hit using a line trace, there we will spawn a BP impact. Now, what's that? The BP impact is just sitting beside the revolver. That's another kind of blueprint class. And that's the BP impact that we're spawning at the position that we shot at. So we get this impact. And also we want to push objects physically. So that's what in the end I'm doing over here. We want to have the buckets that we have shot at want to fall over, fly through the room because we shot them using our revolver. And that is the whole logic behind shooting the revolver that I have prepared for this revolver over here. However, What this revolver and our character, our whole project is not prepared for is actually grabbing, picking up the revolver and, of course, shooting it and dropping it again. So all of that stuff. So that is what we will be doing, right now. First things first, we need to find a way to tell what actors in our scene, what actors in our project can be grabbed and dropped. What can be interacted with? So there are many different ways of doing that. The VR template, for example, made by Epic Games, is using actor interfaces, blueprint interfaces, that you can add on any kind of blueprint actor as you like. That's a good idea in a lot of cases, and we will also be doing this today. But just to show you, or just to mention a few other ways of doing that, you could also add components, so a custom component for grabbing and interaction. You can also just have all the logic of grabbing and doing something with that in the actual actor itself. That would be, very redundant if you have multiple different, for example, weapons, different types of revolvers and guns. In this case, as we only have one, you could do it in there as well. But we want to create it in a different way, and that is using an interface. So the first thing that we will be doing is we will go to our VR first steps content over here and create a new interface. By going with a right click into the content drawer down here and going to the blueprints category, you can go with a new blueprint interface. A blueprint interface is something that you can add to any kind of blueprint class that you're creating to mark it and even to give it functions that will be implementable by each of the each of the classes that is using that interface. In our case, we don't even need to have these functions. We just need to have a way of marking a specific object to be grabbable. That's also what we could call this interface. So I'm creating a new blueprint interface and call it the grabbable interface. So that's the grabbable interface, and we can give this to any actor or actor class that we wish to do in our project. The grabbable interface over here. When you double click on the newly created grabbable interface, it will ask you to name a new function. Normally, that makes sense because in an interface, you can create these functions and do some kind of a layout of them. You don't really do the implementation. As you can see, you cannot really implement something in an interface. You only can tell what inputs, outputs, and other values you have on the functions and what functions you have available. The actual implementation part you are doing in the actors themselves, in the classes. Now, because we are not really doing anything in here, we are just wanting to mark what can be grabbed, we don't need to have any kind of function in there. So I want to have an empty interface. I just went with the delete key over there on the new function on the top right, and now this grabbable interface is empty. That's fine. Maybe later we can add something to it, but for the moment, we just want to have an empty interface. This grabbable interface we want to add to the revolver. So I'm heading over here to our revolver. I'm opening up the BP revolver blueprint class. And to add our interface to an actor class, we need to go to its class settings, which you can find up here in the toolbar. So when you're on the BP revolver, there's the class settings on the top in the toolbar. And there you have a list of interfaces that this actor is using. On the inherited interfaces, there's a little add button. Don't confuse this by the new namespaces introduced in Unreal Engine 5.1. A very interesting topic, but not for now. So the interface is over here. And I want to add a new interface. And I want to go with the grabbable interface that we just a second ago defined over there in our plugin. Now, this is inheriting or using the grabbable interface. Because it is not coming with any kind of function, nothing changed about our revolver itself. There's no function that we have defined for that. But at least our interface is now marking our revolver to be a grabbable object. Let's now create the counterpart to that in our VR hands, because we want to grab the revolver by using the VR hand. So when we go there, we can actually grab the revolver. All right. So in the VR hand, I'm opening that one up. If you don't know where this is, it's in the VR first steps content, BP VR hand. Double click on that, and in here in this one, I want to implement the actual logic for picking up, for grabbing an actor. We are not doing this in the event graph or somewhere over here itself. We want to create a new graph just for that purpose. So in the graphs over here, I want to go with a little plus new graph button, and I'm creating a new graph, and I'm calling that one the hand graph, as all the hand specific logic is now going in there. In that hand graph, I'm creating a new custom event. So I'm going in here, right clicking in the empty blueprint graph, and I'm typing in add custom event to create a new custom event that I will be calling try grab. I want to try to grab something with using that hand. So the first thing that I need to be aware of is my hand already occupied? Is it already blocked? Because if I have something in my hand, I cannot grab something new. Over there for your tree of life in Discord, to create a new event graph, I just clicked over here on the graphs and there on the little plus new graph over here. So this little button. Using that try grab, I first need to find a way of knowing, is this hand occupied? So later what we'll be doing is we will memorize the currently grabbed actor. And that's what we are already doing. We are creating over here in variables a new variable, grabbed actor, the actor that is currently grabbed by this hand. And the data type, currently set to Boolean, of course, that's not what we want to go with. I'm setting this to be an actor object reference. So I'm typing in actor in here, going down there to object types, actor, and go with an object reference of an actor, looking like this. And what I want to now go with is the information if there currently is something grabbed. Is there an actor grabbed by this hand? So I'm using a drag and drop operation, dragging it over here into the blueprint graph, getting the grabbed actor, and I want to know, is there currently a grabbed actor or is this empty? We can ask for this by using, I'm dragging from this blue pin over here, is valid. Is valid will return a Boolean, which is true if it is valid, so there is something, and false if there's nothing. And it comes in two flavors: as a pure function, just giving us this information, or as a macro, combining it with a branch, so we easily can execute one way or the other in our blueprint graph. And I want to go with this little macro over here, the question mark is valid. So now we can ask, or now we are asking, is there something grabbed right now, or is the hand free? So there is something grabbed, the hand is free. If there is already something in the hand, so that the hand is occupied, we don't need to go on. The hand is blocked. We cannot do something with the hand right now. But if there is nothing, I want to go on and see if this hand can grab something. But it's just the hand over there. We don't know where it is in the scene, how many of these revolvers there are. Maybe later there are also other weapons, like I don't know, a rifle or a pump gun. I don't know what else may be coming in the future. So I need to find a way to get only specific elements that are in close proximity to my hand. A very easy way of doing that is to go with some kind of a collision sphere or some radius. In my case, I'm going for the BPVR hand. We already were working on that. I'm just switching over there from hand graph to the viewport. And I'm adding a new component to the hand actor. And I'll be going with a sphere collision. So I'm picking that sphere collision component, and I'm calling that one the interaction sphere, as I can only interact with elements that are inside of that sphere. And this is currently pretty big. Normally, you cannot interact with something that is that far away from your hand. So instead of having a huge interaction sphere, I'm having it selected, and over here on the sphere radius, I'm setting this down to something like 9 or 10 centimeters. So I have a way smaller interaction sphere. I'm maybe repositioning this a bit so it's more in the center of the hand, but there we go. I think this is pretty good point for our interaction sphere. As long as something is inside of that sphere, I can interact with it. So I can grab it or do something else with it. This interaction sphere, I want to use that in the next step to find, for example, revolvers or any other kind of grabbable interface having objects or actors, so I can actually grab my revolver. To do that, I'm preparing a function. In my BPVR hand, over here on the left side, I can create new functions. And the function that we are creating is getting or finding a grabbable element in proximity. So I'm creating a new function by going with the little plus function button over here on the functions. And I'm calling this function, I'm going with find grabbable in reach, something that I can go with from this point in space. The find grabbable in reach comes with a new blueprint graph because it's an isolated function. In here, in the find grabbable in reach, I'm going with my interaction sphere, and I want to check something on the interaction sphere. I want to actually get all the overlapping actors. That is a pure function that I can get from interaction sphere by dragging from it, get overlapping actors, and I'm getting an array, so a list of multiple elements of a specific class, and I'm just filtering for any actor. So basically, I'm not filtering. I just want to get any actor. So with this, I'm now getting every actor that is overlapping with this sphere. In the next step, what I want to do is I want to iterate through all available items and see if they are implementing this interface that we have created. You remember the BP Revolver is using that grabbable interface. And we only want to find elements in the proximity of our hand that is having that grabbable interface. I can do that by using a for each loop that just iterates through all available elements in our array. So I'm doing a process, I'm doing a step for each element in the array. And I'm asking that current iteration. So if I have 20 elements there, this will be done 20 times. And for each time, the current element, I'm asking that one, is this implementing, does it implement the interface that we have provided? So does implement interface is another kind of pure function I can call from over here. And I'm asking if it is implementing our grabbable interface. And if that is true, this Boolean variable over here will return true, otherwise it will be false. That's a Boolean value. And I'm using that Boolean value with an if-else statement, or in Unreal and Blueprints called branch, to see if this is currently implementing, or the current iteration is implementing this interface. So just to go back a step, find grabbable in reach means we are getting all available actors in reach of our hand, and we are asking each of them, are you implementing that interface? And if you are implementing that interface, then we can actually return, because we want to find something, we want to return that found element. So when I have this find grabbable and reach function selected, I can have this outputs over here and add a new output of an actor object reference. Found grabbable. As this is a return node, it will automatically stop the rest of the execution of this function because we have returned something. The rest will be stopped as well. So it's as easy as that. I see a question in the Discord. Why am I using an interface instead of a tag? I could also go with a tag. The thing with a tag is it would be case sensitive. So we all are lazy, and sometimes I'm writing it in this way, then I'm writing it a different way. A tag always needs to be specifically that tag. So it could be an issue later down the road. Also, with a tag, I could not provide in the future additional functions in the interface that could be implemented by the revolver or the rifle or the dynamite that I'm throwing, stuff like that. So that's the find grabbable and reach function. I will now use this find grabbable and reach back in our hand graph.
There is another question in the Discord.
Oh, sorry. Do we need to clean array after function like that one? No, we don't need to do anything like that because this is in a function. As soon as the return node is called, and this will be output back to wherever we are calling this function from, whatever we are doing in here will be thrown to the garbage collection. So we don't need to care for it anymore. It's gone. All right. Back in the hand graph, I will now use my find grabbable in reach by just dragging and dropping. So if there is nothing grabbed, I don't have anything grabbed blocking my hand, I'm trying to find a grabbable in reach. And again, I need to ask, similar to the isValid over here, is there something in reach? Because I could also just go somewhere in the air and there's no revolver there. Yeah, then we cannot go with anything. Okay, so the find grabbable in reach, with that one, I again need to ask, is this valid? So just for later reference, for us to make it a little bit more easy to understand what we're doing over here, this part is the hand blocked? And this part is there a grabbable actor available? And if there is a grabbable actor available, we can go on with this code. I love the little chart there, Christian. It's lovely. Okay, so with the find grabbable in reach, if that is valid, I can actually grab that element. What does that mean in this case? That means that whatever I want to grab, in this case the revolver, should be attached to my hand now, and the hand mesh should be hidden. Of course, with a little bit of work, I could also animate my hand to look like a hand holding a gun, and the gun is fitting exactly perfect in there. I don't have these animations right now, and it's just a prototype, so it's certainly fine to just hide the hand and attach the gun to the motion controller. So what we're doing is we're going with attach from the found grabbable, attach actor to component. So what we're doing basically just is attach actor to component, and I want to attach it to this hand root. I could also go with attach actor to actor, would be the same, but I just prefer the attach actor to component one. And I want to go with snap to target for location and snap to target for rotation. This may result in some very weird behavior, but let's see. I can't wait to actually see what's happening in this case. What's missing right now, however, is to actually call the try grab. Yes, we have this input action grab left, and we have put it on the IMC, on the input mapping context, but we are not actually using it so far. So in our BPVR character, I actually want to now use the grabbing input. For that, in the BPVR character, if you don't have it open like I do, you can just go to your content drawer, and there, this over here, the BPVR character. From there, you can just go with a new graph, and I'm going with a new graph and call it the input or inputs graph in this case. And in the inputs graph, I want to add our grab input action grab left enhanced action event coming from the enhanced input system of Unreal Engine 5.1. And when I'm doing that, when I'm grabbing, I want to tell, in this case, the left hand to try grab something. And now the same for the grab right. I just want to go with the same code, but for the right hand, because we have two hands. Let's see what happens if I'm now executing this. Maybe one more thing to check if our interaction sphere is actually set up to overlap with everything. I'm setting this to overlap all because I really want to make sure that my interaction sphere can interact with anything. Let's give it a try. So there's our hand. I'm going for a revolver. Yeah, it was attached, but then it fell down. Why is that? I can, maybe this one is more easy to grab. Yeah, I grab it, but it falls down. Why is that? You see, the revolver that we have prepared there, that is physically animated. The simulate physics is active, so it falls down. And even after attaching something, it is still physically simulated. So I'm attaching it, it's now changing its position, but then again, it's dragged down by physics. So the moment that the BPVR hand is attaching something to it, we need to tell that element to definitely not be simulating physics, which is in most cases the root component of that actor. So I'm telling that one to get its root component. If you don't like it like this, where you have this crossing of a node and connections, you can just double click on a connection and reroute it down below like this. So I'm getting the root component and I'm setting the simulate physics, which is not available because we didn't check if it is a primitive component. Only primitive components and anything inheriting from that actually do something with physics or collision. So we're casting to a primitive component. So in that case, if it is a primitive component or based on a primitive component, we can set the simulate physics to be disabled because we're doing the attachment and we are disabling the physics. This is important because otherwise the pistol will just fall to the ground again. I'm giving it a try. Now this time over here, going for my pistol. And there we have the gun attached to the hand. Now there's two things missing. As I said, if this is happening, I want to have the hand be invisible. And also, the revolver should be in a slightly different rotation. The rest seems fine for the moment. And also, because my hand is occupied, I should not be able to grab other revolvers as well. Fabian is asking for the input graph. Of course, we can go there. So this is the inputs over here. Really easy. It's just the grab left and grab right that are prepared in the project. To go with the hand left and hand right referenced actors to tell them to try the grabbing. Okay. So after this simulate physics has happened, we want to go on and we want to hide the hand mesh. It doesn't matter if it actually was based on a primitive component, so if it is physically based or not. So in both cases, I want to get the hand mesh and I want to set its visibility to not be visible anymore. And I want to do this in both cases. You can't call that. Have you, Alexandra, have you in your BPVR character, you're going with the hand left, have you in your hands hit the compile button up there? So there's a little compile button, and only if you have clicked that and go back to your BPVR character
Robin,
and you grab from the hand left and right,
just to make it easier for the recording later, just repeat the question. That would be a good idea. That
okay.
if you catch up the recording later, that you aware of the context you are talking right now. Sorry.
All right, no problem. So the question was from the hand left. Some people were not able to get the try grab function, and as we have created this try grabbing on our own, so we can use it from somewhere else. You need to have compile and save clicked and then go back there. Grab from the hand left. So you want to interact with that. That's context sensitive. And then the try grab should be available. So in the next step, sorry? Didn't catch that. Okay, never mind. So the set visibility on the hand mesh, we're doing that in both cases, even if this is not based on a primitive component. In both cases, we are setting the visibility to be not visible. And also, we need to make sure that the object is rotated correctly. We are currently using snap to target for the rotation rule, but it would make sense to rotate the revolver a bit more so it's actually looking 90 by 90 degrees in the right direction. In that case, we can just grab the object, and from now on, because we will do a lot more things with the grabbed actor, the first thing we should be doing is we should set the grabbed actor back over here. So it's much more easy for us to use the found grabbable by memorizing it as this grabbed actor. So we are just using the setter over there and using this from now on. Then we can also get around that down here. We don't need that anymore. I should have done this earlier. So we are now using that grabbed actor by memorizing it to grabbed actor, attaching it, getting off that grabbed actor the root component, and so on. The rest stays the same. Now here in the back, I want to get the grabbed actor and I want to add a world rotation. And in our case, it was by 90 degrees. I hope this is the right direction. It's not minus 90 degrees. We'll see that in a second. I will show you the code, of course, in a second. Don't worry. Yeah, it was the other way around. Now we are pointing the gun at ourselves. Not a good idea. So we have to put this back over here at minus 90. All right, so now with the grabbed actor, adding an actor world rotation by minus 90 on the Z-axis, the actual result should be looking more like this. I have my hand, I can pick up my gun, and it's actually, yeah, it's pointing a little bit upwards. We maybe need to also adjust that, but at least it's pointing in the right direction over here. Just a little bit too much. So we can just give this a little bit more on the rotation side over here. I'm going with the BPVR hand. Now, which one of these is it's this the roll? We're not doing any roll. I would say, I don't know how much exactly. I will go with 45 degrees. Again, I just hope, I'm just playing around with these numbers. I just hope that it is the right direction. And it's not looking even worse than it was before. Yes, this is better, still not good. Okay, let's just go on with this. So is this even up to 90? I'm playing around with these numbers a bit until I get the rotation right. Yeah, this is more like it. Actually, now I'm just pointing the gun in forward direction and yeah. Actually, that looks pretty good. So now that I have grabbed something, I want to be able to shoot it. I want to shoot these buckets over there. And as you know, I have prepared.
No.
Okay, I will mute that. Give me a second. Sorry.
Done.
Thank you. We want to shoot the buckets over there. And I have already prepared the shooting of the revolver. And so far, we are only using the grip button, this button over here on the side. Now for shooting, we want to go with the trigger. So if we have something in the hand, we want to actually shoot it. And we want to do it with the same grabbed actor that we have in hand. So this is the moment, back to the question that before came up by, I think it was Charles, why we are using not a tag, but an interface, because now we can implement an interaction function on our interface. Pretty smart. So on our grabbable interface, I'm opening that one up again. I want to add a new function. So I'm going with add function. And I'm naming that function interact or interaction. Yeah, we can just go with interaction like that. And now we can define what does, I have something in my hand. What does interaction mean? For a revolver, shoot. For a flashlight, turn on the lamp, turn off the lamp, and so on. The interface does not really say what interaction means because the implementation happens in the end on the revolver, on a rifle, on a flashlight, on a dynamite that we want to throw, and so on. So the grabbable interface is now featuring the interaction function over here. In our BP revolver, implementing the grabbable interface, now after having grabbable interface, the interaction function created and hit compile and save, the BP revolver will now show a new category over here. And on the interfaces category, there now is interaction in here. I hope you can see that. If not, make sure that in your grabbable interface, you have hit compile and save after adding that interaction function. However, when you right click on that one, implement event, it will add to your event graph that event interaction. And now you can define what does interaction mean for a revolver. In this case, that's pretty easy. We want to shoot the revolver, which is a custom event we can call that I already have prepared for this revolver over here. Cool. Now we actually need to do the input. So when we have something in the hand, we want to shoot it. All right. Back in our BP VR character, we've got our inputs graph, and I want to go with the IA interaction left and right. Again, we are using the new interaction system, the enhanced input system of Unreal Engine 5.1. So interaction left, interaction right over here. But we have not yet told our hands that they can interact with something. The try grab we have implemented. The interaction, however, we haven't. So back to the BPVR hands. In the hand graph, we have this try grab. Just implemented that. Is the hand blocked? Grab it, attach it to the simulate physics, and so on. Now, just a bit below that, we're adding a second custom event. Right click, add custom event. And I want to call that one try interaction. So try grab or try interact, that's even better. So a prerequisite we need to have for an interaction to happen is we need to have something in the hand, because if the revolver is not in the hand, we cannot interact with it. So we are going for the grab actor once more. And by right clicking on it, we can get a convert to validated get. Maybe that's something new for you, maybe not. I will explain it anyways. So what we did earlier was we went with an is valid, and we have got some or two nodes like this. Now, what you can also do is you can right click on this and convert it to a validated get. So you're going to have basically the getter and the validation as one node, making it even a little bit more easy to read and follow what's going on. All right, so try interact. We are getting the grabbed actor. And as we know that we can only grab something that is implementing the grabbable interface, we can, without checking for anything, without any extra logic, just tell it, grabbed actor, interaction. Because this is coming from an interface, we can tell it to anything. In this case, we are pretty sure that it is using that interface, and it maybe know what interaction means. So I can just go and tell it to do interaction. And that's basically our try interact code. Try interact just sees if we have something grabbed, it is available, and then just tells it to do your interaction. If it's, as I said, if it's a flashlight, it will turn on the lamp, turn off the lamp. If it is a rifle, it will shoot the rifle. If it's a revolver, it will shoot the revolver. If it's a dynamite, it will light the dynamite and we can throw it. Just stuff like that. Yeah, wrong one. Back in our character, however, we need to finish this up over here. So we have our hand left, try grab, hand right, try grab. Down below, we've got the interaction. And I want to, on the left interaction, go with the hand left and go with a try interact. And on the hand right, try interact. And with that, our input is finished. So when we do the input, we are seeing if we have something in the hand, and if we have something in the hand, we tell it to do the interaction, which we have over here in our revolver implemented to be a shoot revolver. So let's give it a try. I'm now grabbing a revolver from over here. And I can actually shoot it. Oh, yeah. But I forgot to do one thing. I'm not sharing with sound, I think. The problem is that this is now happening every frame calculation. So the trigger may not be the best option for that. We can change the enhanced input system, the input mapping and input action, to do it in a like holding style of way. But in this case, I'm just changing the interaction from triggered to started like this. So I will now give it a try because I was basically shooting 6 times in 6 frames. And then my revolver was just empty, where now I want to see. Okay, yeah, I missed that one. Not that easy to aim, as you can see. Ah, now I got one. Yeah, and the other one. And now it's empty. It's just clicking for me. What's missing right now is we also want to be able to drop something again. I want to drop this gun over here so I can get the other one. Of course, I could just go and get my other hand and use that. Yeah, but now you're getting this. Nah. Really hard to aim. So I basically definitely want to be able to drop a gun, drop it down. So what we're doing is we want to finish up our grabbing mechanism that we can also drop something again. In our BPVR hand over here, on try grab, we are asking, is there currently something grabbed? That means if we want to try grab and we have something in our hand, we want to drop it. So I'm adding another custom event in between try grab and try interact, which is try drop. And on try drop, again, I'm asking if there is a grabbed actor. I can just go with a convert to validated get. And if there is something in the hand, I can say try drop. For this to later actually work, I again need to make sure that my input is not handled once per frame calculation. So also, just like we did with the interaction, for the grabbing, I'm not going with triggered, I'm going with that started over here. As I said, the more way this is intended is not to go with started, but to actually change the input action. So it's processed in a different way, but it's way more easy and convenient to just go with started instead. So I'm doing that. In our BPVR hand now, we're doing this try drop. Try drop means we don't want to have a grabbed actor and we want to detach it. So we are detaching it from this object over here. We're keeping the world position. So wherever it is located in the world, we want to keep it there. And we want to set the simulate physics back up. We are getting the root component because we want to have the revolver when we're dropping it. It should be falling down to the floor. Set simulate physics. And yeah, again, the root component could be anything. We know it's based on a primitive component, but Unreal also works in other ways, so we can't be sure. So what we're doing is, what we need to do again is we need to do a cast to primitive component. And on cast to primitive component now, we can activate the set simulate physics from over there. So with that, try drop means if we have something in the hand, detach it from the actor and set simulate physics to true, and in the end, set the grabbed actor to be nothing. By that, we are basically clearing the hand. Let's give it a try and see if now we can actually, wrong controller, this one it is, grab something, have it in the hand, I can shoot. And if I'm clicking that grip button again, we are dropping it to the ground. Oh, still, I don't see my hand. We forgot to activate the visibility of our hand back on. So we're doing that next. Let's go back to our blueprint graph. Over here on try drop. In the end, after we have finished all of our code, we want to get the hand mesh and set visibility back to be active. It's that easy. It's just this one node over here, and we have our hands back after we dropped the gun. Maybe I will restart the screen share now with sound for you. Give me a second. That is way more fun. There you go. So now, when I'm having my VR headset and I'm grabbing my gun over here, I can shoot some buckets and I can drop my gun. And there's my hand. And I can grab the next one. And drop it. And also, of course, the other hand, this is the great thing about this being a separate hand actor or class. I can super easily just get over here and okay. Oh, yeah. Still having physics active. Not supposed to happen, but yeah, can happen. So we have a system for grabbing. I love the Discord chat. We have a system for grabbing the revolver, shooting with it, and dropping it again. And we could now go on with one additional thing that comes to mind. What about passing a weapon from one hand to the other? Because right now, I could grab the revolver with my left hand from my right hand, and with my right hand from my left hand, and all the references would be broken. So back in our hand, where I do the try grabbing, that grabbable in reach, we would need to check to find out if it is currently already grabbed by a different element. Because on grabbing something, we are attaching it, we can simply ask, is that element attached to something else? In the find grabbable in reach over here, I can just ask, oh, that's a bug in Unreal Engine I didn't have for a very long time. I know what to do. I need to restart my Unreal editor. Maybe sometimes you also had this, that when you open some new menus, that happens. Give me a second. I will just, when we are on the VR hand and we have this find grabbable in reach, we can ask that element if it is attached by asking for its attached parent actor. If there is an attached parent actor, that means it is currently attached. Of course, we could say if it is in the right hand, so it is attached, don't go on. But it is way more fun to just, grab it from one hand to the next. In this case, if there is an attached parent, I want to, or I can be pretty sure that it is a hand. So what I'm doing is I'm telling that one to drop, drop it by casting it to a hand. So there is an attached parent actor. I am pretty sure that it is a hand. I'm doing the drop, and then I'm going on with the rest. If there is no attached parent actor, I can directly go to the end. It's now getting a little bit messy over here. So in that moment, what I prefer doing is working with local variables. A local variable is similar to a global variable of an actor. By right-clicking, you can promote this to a local variable, which will be a local variable only available in this instance of the function. Promote to local variable. And I'm going with a L_local found grabbable. So from now on, I don't need to have all of these connections in here. I can just go with my found grabbable reference. So that's making it way more easy for us to understand this complex blueprint function. Because we don't have all of these cross-line connections. So let's go through this once more. If we found something in the reach of our hand, we're storing it now in a local variable. And if it is implementing our grabbable interface, it is actually something that we can go with. But if it is having an attached parent actor, we are pretty sure that it is grabbed by a hand. So we're telling the other hand to drop it first, and then we're grabbing it by that hand. So for a split second, the gun will not be in one of both hands, but as this is all happening in one calculation, there will be not a single frame of simulate physics time for this to actually fall down. So the user will not actually notice at any place that the gun was not in one of both hands for a split second there. Now I need to find a way of actually using the VR headset and both of the controllers from in here. So I'm not sure how to now pass it from one hand to the other. Maybe these are over here more easy for me to reach. Okay, so now I have this in my hand. And I can
How to use
that's not really working with one headset. With one hand. But it should be working. And that's how easy you can build up a grabbing and interaction framework where you can grab a revolver, shoot something, drop it, and even pass it from one hand to the next. So that's it for the learning nugget right now. I want to ask if you like this and also if there are some he said easy, yes, in the Discord. Where you maybe want to go into a little bit more into detail, you want to discuss something, maybe also Christian or Stefan, you want to say something. I just want to round this up with a discussion now.
So let me see. First of all, thank you. There were one or at least two questions I have set to later. So wait for this. So the first one where comes up when we're talking about these. Wait, I'm in the wrong chat. The first one came up when we were in the UI. And let's see, there it is. Why don't you call try grab right after the branch? That comes from Alexandre.
After the branch of where?
So just, Alexandre, if you are here and hearing us, just unmute yourself and you can ask your question directly here in this round. That would be the perfect way. Okay, maybe he already has left.
That's also fine.
And the other one comes from Ape.
Okay.
Ape, if you're here, just reach out to us, unmute yourself, ask your question about the Quest 2. If not, I'm just reading what you have right on the Discord. 1, 2, 3. There we are. So Ape asks, is it possible to export this project that it can work on a Quest 2 in standalone mode?
Yes, you can do that. You would just need to package it to Android for Oculus Quest 2 in the settings. What you need to keep in mind is that, of course, on a Quest 2, some of the visual effects will not look that nice. If we had a little bit more time, I think we could even now go with the preview rendering level and take a look what this will look like on Android Vulkan. I'm a little bit afraid of now clicking on this button because I know that in worst case, it will take 5,000 shaders to compile right now.
I have elevator music prepared. Do it.
Okay, all right. I will do that now. So we can take a look on the visual side, what this will look like on Android on the Quest from inside of this editor, just for the visuals. For the packaging itself, what you need to watch out for is in the project settings, you need to prepare your project settings to be able to output this on Android. That means you need to define the project settings Android tab if you want to go with Vulkan or OpenGL. Since I think nearly over a year now, Meta is recommending Unreal Engine output to be on Vulkan. So you should go with the Vulkan graphics pipeline, not with OpenGL. Also, what you need to watch out for is, of course, some of the code plugins that you may be using could not be working on the Android platform, but it really comes down to what you're doing. Now, this project over here, I think even the assets, they should be working on Android on Quest.
Okay, that was, I was thinking out loud in Discord that it could probably some issues here with the asset.
Okay.
If I'm wrong here, this is good.
I haven't tried, and in 1,100 shader compilations, we know what it will look like on Quest. So give it a short second. I would not see anything that I think would not work. Maybe it looks a little bit weird here and there on Quest, but in general, I wouldn't know why it would not work on that. Bo is having a question there. Please tell me where compiling this for Quest 2. SDK and NDK. So basically, in Unreal Engine 5, they really Epic Games really streamlined the process of setting up the SDKs and drivers required for working with Unreal. What you need to do, so the most easy way, what you need to do is go to Android Studio. You need to have that. Android Studio, it's this tool over here. And when you have Android Studio installed, you just need to go to your installation folder of Unreal Engine. So in the Engine Extras, there's an Android subfolder. And when you have Android Studio installed, it needs to be installed. You run setup_android.batch on a Windows system, or the command on a Mac system, or the shell script over here on a Linux system. And you have everything set up as required by the engine. So yeah, so Bo is just saying that he's on a low spec machine. That should be no problem for mobile development, because also the projects are more mobile content there. Should be no problem. You just need to have Android Studio installed, run this setup Android, and everything should be installed in file. You need to restart your machine.
But for example, the process you're doing right now, of course it's better to do this on a bigger machine, right? Change to Vulkan shader and all this stuff.
Of course, everything needs to be processed, and processing power is just making it more swift.
Yeah. Okay. Yes. So this is what we see right now. This is still not ready, but
no, it's still loading. So yeah, but
basically you get an idea, right?
Yeah.
Yeah. Yeah. Cool.
I mean, as soon as this is,
please compile, give the APK in the Discord, and we can all
shoot around.
Shoot around, yeah.
Like cowboys and bandits.
Okay, Alexandre reached out again and told us that his question was about the timing of the try grab, but he already figured it out. Okay.
All right. Okay.
Good. Other questions?
So now the shaders are compiled, and just for comparison, I mean, you can super swiftly switch between them. This is without changing anything about the scene. What this without changing anything would look like on Quest PC. I mean, of course, you could now make it look better on Quest on Android. So you will not be stuck with that, don't worry. But just out of the box, the content would look like that.
So you can prepare the screenshots for the store in this version and deliver the other one.
I wouldn't say that it is that this has never happened before.
No, it's not. No,
never.
It's not an official advice from us. Please don't do it. Yeah. Okay.
Okay.